In this video, we're going to talk about the property of equality for exponential equations and for logarithmic equations. Then we're going to do a few examples of solving equations for x. So the property of equality for exponential equations is that if b is a positive real number other than 1, and you have b to the x equals b to the y, that's going to occur if and only if x actually equals y. So take a look at our example here. It says if 3 raised to the x equals 3 raised to the 5th, then x equals 5. Well, so how does that work? So it's saying that because our 3's are the same, our bases are the same, that we're able to cross those out essentially and say, okay, well that means that x equals 5. And it works the other way as well because it's an if and only if definition. We're able to say that if x equals 5, then you could write 3 raised to the x equals 3 raised to the 5th. So it's really important here to make sure we're looking for our bases because it's all about that base, So take a look here at the property of equality for logarithmic equations. It says that if b, x, and y are positive real numbers and b doesn't equal 1, then if you have the log base b of x set equal to the log base b of y, that's going to occur if and only if x equals y. So what's that saying? Let's look at an example. It's saying that if the log base 2 of x equals the log base 2 of 7, that because they both have the log base 2, we're able to kind of just like cancel those out and say, okay, well that means that x equals 7. And it works backwards as well. If we said that x equals 7, we could say that that means the log base 2 of x equals the log base 2 of 7. So a question gets brought up. Does the domain of the logarithmic function generally include all real numbers? And the answer there is no, it doesn't. So you need to check for extraneous solutions when you're solving. Let's do some examples here. Because we're going to be mostly practicing our properties, none of these solutions will be extraneous. They'll all work out. So we're going to be solving each equation for x. So in this first example, we have 2 raised to the x equals 32. Well, we can take that 32 and we can rewrite that. So if we have a 2 raised to the x, 32 is actually an exponential of 2. So 2 to what power is 32? And that answer is 5. So here I've got same bases and I'm able to cross them off. And that's going to leave me with x equals 5 as my solution. For letter B, we have the log base 4 of x minus the log base 4 of 8 equals 0. By simply adding our log base 4 of 8 to both sides, that's going to give us the log base 4 of x equals the log base 4 of 8. And here we see that our log base 4's match. So we can essentially kind of cross them off, leaving us with x equals 8. Problem C is going to work similar to what we just did. So we'll add that natural log of 3 to both sides, which will give us the natural log of x equals the natural log of 3. And because they're both natural logs, we're able to kind of cancel those out and not look at them to see that x is going to equal a 3. Letter D is going to be very similar to letter A. That we're looking for a base and how we can rewrite those. Because we have a 1/3 to the x power, we can actually look at that as a 1/3, or sorry, not in 1/3, but in x, wow, having troubles, a 3 to the negative x. There we go. And 3 can also be rewritten, so 9 can also be rewritten as a 3 squared. So we put our 3 squared down, and now we can look, and because they have both bases of 3, we're able to cancel those bases out, and that's going to tell us that, okay, negative x equals 2, and we can solve from there. We'll divide both sides by -1 to get us x equals -2 as our solution. For problem E, we have e to the x equals a 7. So we're going to kind of use the backwards portion of this. So instead of going, gosh, well, we can't write 7 with a base of e, what we can do, though, is we can take the natural log of e to the x, and we can take the natural log of 7, and using the one-to-one property, because the natural log and e are the same base, they cancel each other out there. And that leaves us with x equals the natural log of 7 as the solution. So for letter F, we have the natural log of x equals -3. Again, we can do something similar if we're trying to solve here. If we take this and we say e raised to the natural log of x and e raised to the -3, that allows us to cancel out our e and our natural log using the inverse property. And so this is going to allow us to say that we have x equals e to the -3. And that would be our solution. Let's look at 2 more. Doing these just kind of takes some practice, and once you get the hang of it, and once you get used to being able to move these and manipulate them and use the properties, it becomes easier to do it. Here, for letter G, we have the log of x equals -1, so that's a base of 10. So if we take a 10, and we say, okay, this is the 10 raised to the log of x, and 10 raised to the -1, it allows us to cancel out our 10 and our log, which drops down our x, leaving us with 10 raised to the -1 as our solution. So this is another example of the inverse property. We can actually break this down a little bit farther because we know what 10 to the -1 is. This is actually 1 over 10, and that would be our final solution here. For letter H, we have the log base 3 of x equals 4. So we're going to do something similar to what we did for E, F, and G here. For E, F, and G. So we're going to use the inverse formula. So what do you think we would do? Go ahead and try this one on your own. So push pause, work it out on your own, and then push play when you're done, and let's see how you did. So because here we have a base of 3, we could have taken a 3 raised to the log of 3x, log base 3 of x, and 3 raised to the 4th power. That allows us, using our inverse property, to cancel out our 3 and our log base of 3, leaving us with x equals 3 raised to the 4th power. Then we would simply find what 3 raised to the 4th power is, which is 81, and then that would be our final solution. So it's called the inverse property because, again, we're able to look at the bases, and because the bases are the same, that's what allows us to cancel those out. So it's really important to make sure that we're paying attention to what our bases are and what properties we can use.